Welcome to the lair of the Batty Boffin.
Hi there Batty fans, time for a little bit more electricity with the Batty Boffin. Now if you've seen some of the earlier videos, you'll have known that we've been talking about voltage, current and resistance, which are three of the things that describe how the electricity flows around a circuit such as this one. The symbols we use to represent them in formulas are V, I, don't know why it's I, should be C, but there you go, and R for resistance. And in the last video we found out this wonderful thing called Ohm's law, which is that, which tells us how voltage, current and resistance are all linked. Basically what it means is if you put more batteries in there so you've got more voltage, you've got more electricity going round, more current. On the other hand, if you put a bigger resistance in there, then the current is reduced. That's all fairly easy really. Today we're going to be using that formula. But just as an illustration, I have got my little circuit here, which is this up here. We've got a set of batteries up here. I've got 4 AA batteries. Each of those is 1.5 volts. So I've got 3 volts being generated here and it's linked up in series with another 1.5 volts twice. So that's 3 there and 3 there, 6 altogether. And I can just demonstrate that by measuring it with my multimeter, which I've set onto the 10 volts DC, so that means one swing of the needle will go from 0 to 10 volts. It'll be a little bit far for you to see, but believe me, I'll read out the figures as they happen. So first of all, I'm going to switch on my circuit, and then I'm going to measure the voltage put out by these two. And yep, that's a little under 3. And then for these two, yep, again, a little under 3. So if I measure from here to here, the whole voltage being generated altogether should be a little under 6. Yep, about 5.8 I make it. So this is generating little under 6 volts here, and my switch is in the closed position, which means electricity can flow round, and so it's getting to my bulb at the bottom. My bulb is marked 6 volts, 0.5 amps. So that's what's marked on the bulb there. You'll find that marked any bulbs you get, they've got little markings on them. So I'm just going to measure the voltage here. I'm just going to draw it in. So here's my voltmeter. Voltmeters are always wired in parallel, like that. So that means I'm putting my 2 connectors like that, one either side of the bulb. So you see me here doing it. We have one there, oops, wrong way around. And there we are measuring, yep, about 5.8 volts. So all the electricity that that's putting out is being used up by my lamp. Now, with that information, we should be able to work out what the resistance of that bulb is, because we know the volts, we're going to call it 6 for ease of calculation. We know the number of amps because it's marked on the bulb, so we can use this formula to calculate the resistance. Now, we actually want to know the resistance, but this formula says V equals, not R equals. So we need to kind of rearrange that slightly. So what I'm going to use is a wonderful thing called a formula triangle. You may have come across these. Here are my things: V for voltage, I for current and R for resistance. And they fit in a triangle. And this is a great way of laying them out because it shows you all the different formulas. What you do is you cover up the things you want to know, and what's left is the formula. So to get it this way round, if I cover up the V, I'm left with I times R, I times R, I times R. If I wanted to know the current, I'd cover that up. And what's left is V divided by R, V over R. We, on the other hand, want to know what the resistance is. So I'll cover that up, and what we're left with is V over I. So in other words, resistance is futile, is also V over I, the voltage divided by the number of amps. In our particular case, that's R equals V, our voltage is 6, over amps is 0.5. Please note that is 6 divided by 0.5, not 6 times 0.5. If you're not sure about dividing by fractions, 0.5 is a half, check out some of the Batty Boffin maths videos where we talk about that kind of thing. But here we go with that. 6 divided by 0.5, if you're not sure, get a calculator or see some of the other videos, comes out as 12, and that is 12 ohms. So that's the first one. Go and get yourself a couple of custard creams or perhaps bourbon, so more your fancy. I'll wipe down this board and there'll be one for you to do in a minute. Right, here's one for you to have a go at. We've got the same circuit as we had before, except this time I've changed the battery. Instead of having a 6-volt battery, we've now got a 3-volt battery. The lamp is the same one as before. I've just marked it as a 12 ohm resistor. It's the same one as we had before. But this time, since we've got less voltage, there'll be fewer amps going round the circuit. There's less pushing power. So could you use this formula triangle to calculate I, the current? Remember, you cover up the thing you want and what's left is the formula. So have a go with that and then I'll work through it with you. Welcome back. Hopefully you had something looking like this. We want to calculate the current. So cover up the I and what's left, V over R, is our formula. So the current is equal to the voltage divided by the resistance. The voltage in our case is 3 volts. The resistance is 12 ohms. 3 divided by 12, you can either call that a quarter or 0.25 amps. Amps often come out to quite small numbers, so sometimes we use the unit milliamps. Each milliamp is 1,000th of an amp, like meters and millimeters or litres and millilitres. This is amps and milliamps. So 0.25 amps, to divide that by 1,000, we jump the decimal place 3 times. Again, if you're not happy with this, look out some Batty Boffin maths videos. We're going to jump that decimal point 3 times. So 0.25, I'm going to put another 0 there because we're going to need it. 1, 2, 3 jumps becomes 250 milliamps. So a quarter of an amp, 0.25 amps, or 250 milliamps. They're all the same answer. Okay? One more break for a cup of biscuits or something, and I'll give you another one to do. Right, here's your final one. This time we've got 12 volts worth of battery. That's the kind of thing you get when you have transformers for things like Christmas lights. They often run off things like 12 volts. And this time we've got 100 ohms worth of lamps there. So again, we're going to use this formula and work out the current. Okay, you have a go with that. Here's what it should look like. Again, we cover up the thing we want. What's left is the formula. So I is equal to V over R, volts divided by resistance. Our volts are 12. Our resistance is 100. So we need 12 divided by 100, which is 0.12 amps. And again, if we want to turn that into milliamps, we need to move that decimal point 3 places. So that's 1, 2, 3 over that 0 that's not there. So that is 120 milliamps. There, hope you got that. I'll see you next time for a few more of these, Batty fans. Bye for now.